So you did 2 from this. 2 squared is 4, times 2 is 8, plus 3 is 11, minus 6 is 5, times 6 is 30.
Okay, I said 4 in there, so I didn't get 30. I'll forget what I had there.
Alright. So it should have been 30 over 5 and come out with 6. You do this to come out with 121 minus 21 is 100, divided by 10 is 10, times 5 is 50, divided by 2 is 25. So on the bottom you'll have 3 plus 2 is 5. Should have come out to be 5.
Give the order of operations. We didn't have homework last night, did we? No.
The winning number is 4.
Yes!
Give this a try and bring an answer up. See if you can solve that. So you have log of 3x plus 10 closed quantity equals 2. Do you remember what the base is on a log in which the base is not written?
No.
That's for log natural. That's the base.
Is this the second number in the parentheses?
No.
It's number before x.
It's not a decimal. It's the number that goes here for the base at the subscript. If it's not written, all logs are this base if it's not written. There's a 1 in it.
1.5.
No. Should be 10.
I said that.
I didn't hear you.
I said the second number in the parentheses.
Well, it just happens to be a 10. It just happens to be a 10. It's golly. All right. So, do you remember the format? If I'm going to change this into exponential form, what do I write first? This one. Well, I'm asking you.
I don't know.
10 to what power?
The third power.
Not the third power.
Second.
The second equals 3x plus 10. What is 10 squared?
100.
100 equals 3x plus 10. If I subtract 10 from the left, what's left? 90. And divided by 3?
60. No, that was stupid.
30.
30. Should be 30. So the answer is A.
Yes.
Solve 11 to the 4x power equals 48. Round to the nearest 10,000th. We have to solve 11 to the 4x power equals 48. Step 1 when you solve an exponential equation is to take the log of both sides. And remember by rule that when you have an exponent here, you can bump it out to the left. So make it 4x log 11 equals log 48. And then you're left with 4x on the left. You're dividing both sides by log 11. And that's still a 48 there, and log 11 is on the bottom. So when I go to find x, I need the answer for log 48 divided by log 11, and then divide that answer by 4. The answer does come out to be 0.4306, so that is A. Alright, so on this one, notice that you have your base 25, so it's going to be log base 25, and the result is what goes here. The exponent is what it's all equal to. There are no equals x's in here, so these cancel out except for this one, B. Alright, so we have to take the log of both sides. So log of x minus 15, quantity to the 3/4 power equals 27, and that should be log. Try to change it. There we go, strange looking L. Log 27. Move the 3/4 out to the left and be left with this. Now if I divide both sides by 3/4, if I divide something by 3/4, it's the same as multiplying by what? If I divide by a fraction, I can do something to it and then something else. If I divide by a fraction, I flip it and then multiply. Flip and multiply. So you would have 4/3 over here. Alright, what can I do with this 4/3? Where can I move that 4/3 to? Do you remember from the example? On the right side of the 27 and make it the what? Exponent. If you do this part there, I have 2 G's in my log. I just need one. So you come out with 27 to the 3/4 power is the same as 11.8446, and we'll stop there. So we're going to have that equivalent to this. So in order to get something that equals this from x minus 15, I would have to add 15 to this. If I add 15 to that, I come up with 26.844 and so on. Clearly, choice C would be the answer. Alright, so we have log of x plus 9, set it equal to 1 minus log x. Any idea about what we should do first? Anything that we can do? We have 2 logs, they're on separate sides, and they both have x's in them. Anytime you have an equation to solve and you have 2 different x's and they're on the different sides of the equal sign, what should you do? Put them on the same side. Yeah, so let's do this. Log x, we're moving this from over here. Instead of minus, it'll be plus. And log x plus log of x plus 9. And set all that equal to 0. Do you remember from the property of logs that we went through before what you can do to condense this when it's addition? Do you remember this property?
You make it.
So how can I condense down log x and log x plus 9? If you have addition, you
X squared plus 9.
that's close. That's real close.
X squared plus 9x.
You would have 1 log, and you would have x. You would have to multiply them together. So x times x plus 9. And then all of that equal to 0, or a 1. Okay. Now what can I do? Do you remember what base the log is if it's not written?
10.
10. Okay, so if we put 10 in there, now do you remember how to go from the log form to the exponential form? What number goes down first? Something to a power equals something. What's that first something we have to put down? It's got to be in this form here. There's something to a power equals something. What goes here? Your choices are this, this, or this goes in here. Not the 1.
X and then
Nope.
10.
So is 10, yes. 10 to some power. What is the power? 1 equals what? Yes. That's right. Okay, so we'll shorten this up a little bit to have room to work. Move that up there. And I'm going to bring this down here and continue on. So I'll recopy it. 10 equals x times x plus 9. 10 to the first is just 10. If I multiply through on the right side, I get x squared plus 9x. What kind of equation is this starting to resemble? Has a squared in it? An x quadratic, yes. So what can we do to finish this off? To put it in a quadratic form? That's right, it's got to be in the ABC form, and we have x squared plus 9x. What's missing on that side? Minus 10, yeah, you got to move this over. So you'll have 0 equals x squared plus 9x minus 10. Now, how you solve this is up to you. You want to use quadratic formula, or maybe we could factor it. Let's see if we can factor it as, and we give it a try. If I have a minus on this end, that means you're going to have alternating signs. Actually, there should be an x here, and then we'll put in a red sign of minus. Two numbers, one positive, one negative, that multiply to give me a negative 10, but add to give me a positive 9. There's a negative 10, its factors 1, negative 1, 10, 1 and negative 10, 2 and negative 5, negative 2 and 5. Which pair of numbers will give me a positive 9? Negative 1 and 10 is right. I said negative 1 and 10 and wrote them in the wrong spot. Good grief. Negative 1 and positive 10. Yes, there we go. Okay, so what would be the solution? Shorten this up some more. What would be the solution from this set of parentheses? If I set x minus 1 equal to 0, what do I get? So x equals 1, or x plus 10, x equals negative 10. Which choice is that? 1 and negative 10? 1 and negative 10 is up here, yes. Choice A. Can we put that in log form? All right, what do I do?
Log of 3, 9 equals 2.
Yes, that's right. What about this one? Yeah, log base 4 of 64 equals 3. Can you put this in exponential form?
Two to the fifth equals 32.
2 to the 5th equals 32 is right. What about this one? Yes, 5 to the 4th equals 625.